stopped powering on, so I want to find out and also show you how to fix it. Thanks for looking out for our videos. Thanks for subscribing, and if you haven't yet subscribed, find the subscribe button. It's a red rectangle with the word subscribe inside. Click on it, you'll be subscribed. So today we have ourselves a Tecno C5 or Tecno Common C5, and this phone stopped powering on, so I want to find out and also show you how to fix it. So I will not show you how to open because I already opened, but I'll just review how you would open this phone. So first of all, you will remove the back plastic, snaps in there, take out the battery. With the battery taken out, you'll see there are screws around the peripheries. Remove all of those, and the next thing would be to now pry the plastic out of place. So I use a surgical blade and reach out from this side and move around and lift it out of place. So the back cover is out of place, and then now the phone doesn't power on. So initially, first thing you will do is to inspect the power button, and of course, having inspected the battery. But for the battery, what I did, I used the voltmeter in voltage mode and set it to a maximum voltage of 20, a maximum read voltage of 20. So I set this to DC, maximum voltage of 20, and I'm trying to check my battery. So I will do this, and then with one probe there, it reads 4.25, and this shows me the battery is fully charged. So the battery is not the reason why this phone isn't powering on. Now when I try to press the power button, I feel nothing's going. I don't feel any click whatsoever, so I am suspecting the power button. So we'll have to get the motherboard out. Now I had already removed the screws that hold the main motherboard. There was a screw here, unscrew that. There was a screw there, unscrew that, and the screw there. That should give you the liberty to be able to take out this motherboard. But now there's a thing you will need to note, is that there is most likely a fiber connecting this main board to that lower subboard that carries the network antennas and the vibrator. So what I'm going to do is now to reach out into the phone and attempt to lift out the motherboard, starting from this side. I'm afraid there are fibers at that point. Now I'll take that. First of all, this is out of the socket. That's the camera. I know it's not necessary, but right now I'll use all the intuition there is. Okay, try that. Now I feel some resistance, which leaves me wondering whether this board is glued onto the frame using some sort of glue underneath that prevents it from shifting. So that's where I bring the surfaces of my hot air gun. Set it to about 150 degrees C, and then I do not want to damage my rear camera lens, so I'm going to first remove it out before I subject the board to any sorts of heat. It's also glued down, so it's making it hard for me. Let me try to move it around and not blow hot air directly into the lens. Attempt to lift it. So I suspected right. This board was held held into place using glue. So usually when you meet resistance, just be patient enough and do carefully. So our camera module is out, and then next we try to pull out the main board. So right now we are interested in the power section because our main problem is that we can't get this to turn on. Now will again employ the services of my hot air gun to help me remove this tape at the back, since it conceals fibers that transmit signals from the main board to the lower subboard. And be patient with it, because too much heat will actually cause it to shrink to just be sufficient for me to expose the fiber. So that's the fiber running from the main board to the lower subboard that carries the network antennas. Now I'm going to move it just slightly. I don't have to take it all the way. Now with your lift it carefully, draw it backwards. As you apply heat on the ribbon, it's also glued onto the chassis of the phone. Now if you thought you don't have a refill station to provide for your hot air, you could use a hair dryer. That's something you can easily find around the homestead. Now we are interested in the main motherboard. Okay, now if you turn up this board uses on motherboard buttons. So the first thing is we shall check for the viability of the button itself. It's also not unspoken of the power buttons undergoing oxidation and causing the current not to be transmitted. Right now, at this point, I will need the services of my multimeter and place it in continuity mode, because basically switch is conductor with broken contact, so when contact is re-established, current has to flow. Now I'm checking for continuity, the voltmeter in continuity mode, that's also sometimes called diode mode. My minimum resistance here is 1 ohm. Now on the board I'll check for that and that. Now since the power button is designed such that there is always a 3.3 volt trigger voltage at the power button, which gets shorted to the ground and triggers the power management IC to initialize the powering sequence. I will look for the ground terminal, put my ground probe on it, and put the positive probe on the other terminal of the power button. First of all, I'll try to establish which of them is the ground terminal. Of course, this is the ground terminal. Okay, now which makes that the 3.3 volt terminal. You will bear with me, there's only so much area under the camera, so now whenever I click, I want to get the resistance value, and this should be at least below 4 or 5 ohms. Oh, in case you weren't seeing, these are the probes or contact points that I was interested in: extreme left and extreme right. The extreme right, when I check for continuity from the ground plate of the charging port to it, reads a resistance of 1 ohm, which means this is the grounding pad. Now leaving the second one to be the pad that provides the 3.3 sense voltage for the power button. Now having confirmed that, the next thing is now to do a live check with the battery plugged in and say if I get the 3.3. So this will have to be set in voltage mode at a maximum voltage reading of 20 volts. DC, of course, do not set it in AC because you won't get any usable results. At this point I will have to summon back my chassis and put the board back right in. Okay, because I want to hook it up live and check for the 3.3 volts availability. Okay, so the first thing is we're going to plug back this ribbon fiber transmitting signals from the main board to the lower subboard. Okay, that's plugged in. Now I have a bit of a dilemma here in that this board actually turns upside down. Okay, I'll turn it this way since I do want to access its battery contact points. So I will plug in the battery, take back my into voltage mode right there, and hook the battery in. Of course, my ground probe.